Imagine just clicking a like button on a decentralized social network and you just like the post.
Right, like normal.
Exactly, like normal. You don't get hit with some wallet pop-up demanding a $5 gas fee. You don't have to, scramble to find a browser extension or wait 30 seconds to sign a transaction. It just works instantly.
Yeah, which is kind of the holy grail here.
It really is. But then take it a massive step further. Imagine an internet where artificial intelligence builds, tests, and deploys your custom apps just from you talking to it in plain English.
Just voice commands.
Just voice commands. And the entire back end, the front end, the database, it's all hosted natively on a tamper-proof blockchain. Not AWS, not Google Cloud.
I mean, it sounds like pure science fiction, right? Or at the very least, a wildly optimistic Web3 pitch deck from the last bull run.
Oh, totally.
But as we survey the technological landscape in mid-2026, this isn't just theoretical vaporware anymore. This is the actual live architecture being deployed right now.
And that is our mission today. We are taking a deep dive into the internet computer ecosystem, widely known as ICP. And we brought a massive stack of sources to parse through for you.
Yeah, it's a heavy stack today.
We're dissecting the incredibly dense Internet Computer for Geeks protocol overview, the highly specialized 2025 Swiss subnet white paper, a radical network governance proposal titled Mission 70, and some recent 2026 market analyses from Yellow.com and DEX Tools.
So we are synthesizing all these documents to really extract the truth about how this specific network is attempting to forcefully pivot the entire industry.
Right.
Because for years, a dominant narrative has been, blockchain as a global ledger for finance.
Just moving money around.
Exactly. But the overarching goal of the ICP architecture is to shift that paradigm to blockchain as a literal world computer. So we're going to break down the mechanics of how that actually functions, and crucially, what their aggressive new tokenomics mean for you as an active participant in this space.
Okay, let's unpack this. Because to understand this grand vision of a world computer, we really first have to thoroughly understand the engine room.
Oh, absolutely. The bare metal.
Yeah. The fundamental building blocks of this network execute code in a completely different way than an EVM chain like Ethereum or a parallelized chain like Solana. We keep seeing this term plastered across all the technical documentation canisters.
Canisters, yeah.
But the docs go out of their way to note that these aren't just standard smart contracts.
No, they're not. They are essentially WebAssembly or WASM execution environments.
Okay.
And because they compiled a WASM, developers aren't forced into bespoke crypto languages. I mean, they can write in Rust, Python, Matoka.
So whatever they're already comfortable with.
Exactly.
Yeah.
But the true mechanical breakthrough, the thing that actually allows it to function as a server rather than just a ledger, is how canisters handle data. The protocol overview calls this orthogonal persistence.
I have to admit, orthogonal persistence sounds like something an engineering professor says just to confuse the freshmen.
Oh, it completely does. The terminology is super dense, but the underlying mechanism is incredibly elegant.
Okay, lay it on me.
So think about traditional software development. If your program needs to remember something across sessions, say a user's profile picture or an updating account balance, the developer has to explicitly write code to serialize that data.
Right. Open a database connection.
Exactly. Open a connection to an external database like PostgreSQL, save it, and then write entirely separate logic to query it back later.
Which is tedious.
Super tedious.
Oh.
Orthogonal persistence just eliminates the database entirely. The developer just writes code as if the program will run in active memory forever.
Wait, really? Forever?
Yeah. Underneath, at the node hardware level, the blockchain protocol automatically takes the active memory pages the program is using and seamlessly hashes them into the state tree.
It's like going to a restaurant where the chef not only cooks the food, but, magically pays for the electricity, the rent, and the dishwashing, rather than charging you a separate utility fee for every single bite of food you take.
That is a great way to put it.
Which leads us right to the reverse gas model. DX Tools highlighted this in their recent market analysis as the major friction killer for mass adoption.
What's fascinating here is how this single architectural design choice just completely attacks the core user experience problem of Web3.
Because right now, the UX is terrible.
It is. On legacy networks, the user pays the compute cost of gas at the exact moment of interaction. But in the reverse gas model, the developers prepay for their own applications' compute and storage.
And they do that using cycles, right?
Yes. They use cycles. Cycles are this stable computational unit created by converting and irrevocably burning the native ICP token.
Meaning, as a user, my experience is basically identical to interacting with Web 2. I just open a browser, navigate to a URL, and interact with the dApp.
Exactly. You don't know it's Web 3.
Right. I don't need a wallet extension installed, and I certainly don't need a pre-existing balance of tokens just to browse a social feed or, like, play a game.
And the broader implications of that are profound. This is the mechanical prerequisite for decentralized SocialFi and complex on-chain gaming.
Because you can't have a fast game if you're signing transactions every second.
Mathematically impossible. You cannot build a fast-paced multiplayer game if every single player movement requires a cryptographic wallet signature and a variable network fee.
Right.
The reverse gas model allows the decentralized app to operate under the hood while feeling totally normal to the end user.
But to run a full web application, serving the front-end interface, handling the back-end logic, managing the persistent data storage, you need serious, sustained speed. And the wiki source in our stack claims ICP can process 5 million transactions per second.
Yeah, that big 5 million number.
Which is huge. But looking at the mechanics, I have to assume that number isn't referring to complex, state-changing smart contract executions.
You're hitting on a really crucial distinction in blockchain analytics there. The wiki explicitly notes that comparing blockchains purely by a monolithic KPS metric is highly misleading unless you compare within a single problem domain.
Right, apples to apples.
Exactly. A transaction that simply reads a balance is fundamentally different from a transaction that swaps 3 different assets through a complex liquidity pool.
So how does the internet computer separate those domains to hit that massive 5 million number?
So the network splits interactions into 2 distinct pathways. You have query calls and you have update calls.
Okay.
Query calls are read-only. When you load the front page of a decentralized website hosted on ICP, you are making a query call. Because it doesn't change the state of the canister, it totally bypasses the massive overhead of network consensus.
Oh, so it's instant.
It executes in milliseconds.
Well, the update calls are the actual heavy lifters. Like if I transfer a token or publish a new post to that social network, I'm actively changing the state.
Right. And that state change must be routed through the full cryptographic consensus protocol across multiple nodes to ensure security.
Which takes longer.
Update calls take roughly 1 to 2 seconds to finalize. So when marketing materials tout 5 million TPS, the vast majority of that throughput is query calls serving web data.
Okay, that makes sense.
It is legitimately web speed, but understanding the mechanical split between reading and writing is essential to cutting through the hype.
But having an incredibly powerful frictionless engine is ultimately useless if it's stuck on an isolated island. Like blockchains have historically operated as walled gardens. To move an asset from Ethereum to an alternative layer 1, you have to use a centralized bridge.
And those are nightmares.
Exactly. As we've seen time and time again, those bridges are giant honeypots for hackers. But the Geek's overview details ICP's solution to this, called chain fusion.
Chain fusion represents a radical departure from the traditional bridge model. It allows the internet computer to natively read from and write to other networks, specifically Ethereum, EVM-compatible chains like Polygon, and even the Bitcoin network.
Without a bridge.
Without any third-party intermediary at all.
I need to deduce how that's technically possible, because if an ICP canister is going to send a transaction on Ethereum, it has to sign that transaction, which means the canister has to hold an Ethereum private key.
Right.
But if a single node holds a private key, that's a massive central point of failure.
You've identified the exact cryptographic hurdle, and the solution detailed in the protocol is threshold ECDSA elliptic curve digital signature algorithm.
Okay, another big term.
Yeah, but simply put, the private key never actually exists in its entirety in any single location. Instead, the network uses multi-party computation.
Okay.
The private key is mathematically split into shares distributed across the independent node providers within an ICP subnet.
So imagine a massive digital bank vault that requires 50 different people to turn their individual keys at the exact same millisecond. If a malicious actor compromises one node, they just get a useless string of garbage data.
That analogy perfectly captures the security model. When the canister needs to sign an Ethereum transaction, the nodes compute the signature collectively without ever reconstructing the full private key.
Wow.
And add to that a feature called HTTPS outcalls, where the canister can securely reach out to the standard Web 2 internet to pull data from Ethereum RPC nodes without needing centralized Oracle feeds.
So it just talks directly to the web.
Exactly. The subnet reaches consensus on the data pulled from the web and then acts autonomously. The canister is literally acting as a decentralized, automated user on the Ethereum network.
That level of interoperability is wild. But I want to pivot to the physical world, because the 2025 white paper we have focuses on something incredibly controversial, the Swiss subnet.
Oh yes, this one caused a stir.
Big time. The nodes powering this specific subnet are physically and geographically constrained entirely to Switzerland and Liechtenstein.
Right.
Let me push back on this because it feels completely antithetical to the core ethos of Web3. I mean, blockchain is supposed to be borderless, permissionless, and globally distributed.
Yeah.
Creating a geofenced, Swiss-only server farm feels like a massive regression back to centralized legacy finance. Purists must be absolutely losing their minds over this.
They are, and it has sparked intense philosophical debates across all the developer forums.
Yeah.
And the purist critique is entirely valid. But if we connect this to the bigger picture of adoption, this precise geofencing is the necessary bridge for institutional clients.
The suits.
Exactly. A borderless, globally distributed blockchain is a literal regulatory nightmare for a Swiss private bank or a European healthcare provider. They operate under strict legal mandates regarding data residency.
Right. Patient records or proprietary financial data legally cannot leave Swiss borders.
You nailed it. It's the classic compromise. You want the cryptographic immutability and transparency of a public blockchain, but you legally require the physical jurisdiction of a traditional server.
So how do they pull that off without exposing the data to the rest of the public network?
The white paper outlines a highly specialized architecture to satisfy those legal requirements called the canister and canister model. It leverages nested execution.
Nested execution, okay.
Yeah, so a public-facing canister can host and invoke private nested canisters within a secure environment. The broader network can verify that a computation occurred without ever seeing the sensitive logic or data inside that nested canister.
That's clever. The application that really stood out in the white paper was digital legacy planning.
Oh, that's a fascinating one.
They detail a system for automated asset transfer triggered upon a user's verified death. The tokenized inheritance rights, whether that's real estate, equities, or digital assets, just execute automatically based on a smart contract.
It's seamless.
And because it lives on nodes physically protected under Swiss law, it carries actual legal weight.
It basically automates the probate process. It removes the friction, the exorbitant lawyer fees, the multi-year court delays, executing a trustless legal system within a globally respected jurisdiction.
Okay, so we have this enterprise compliance and we have the frictionless user experience. But what is actually driving the broader market sentiment right now? Looking at the yellow.com analysis, the ICP token spent 2025 lingering near $2 lows.
Yeah, it was a rough patch.
But as of mid-2026, it has pushed past $3.30. And the primary narrative sustaining this fresh wave of volume isn't Swiss banking, it's the on-chain AI build-out.
The convergence of artificial intelligence and decentralized cloud architecture has completely dominated the 2026 cycle. The Mission 70 document outlines a foundational platform called Caffeine.ai, heavily leveraging the network's computational capacity.
Right.
They refer to it as the dawn of the self-writing cloud.
Here's where it gets really interesting. The documents describe a workflow called vibe coding, and it essentially turns the blockchain into a wish machine.
A wish machine, yeah, I like that.
You, the user, don't need to know a single line of Rust or JavaScript. You just use natural language prompts. You tell the AI, build a secure, hyperlocal social network for my neighborhood to share tool rentals, ensure it has no tracking, no ads, and full encryption.
And it just does it.
The AI generates the code, tests it, and deploys it directly as a canister.
It entirely abstracts away the traditional software development pipeline. But this raises an important question, right? Why execute this on a blockchain at all? Why not just use OpenAI or Anthropic, hosted on a standard enterprise cloud?
Well, if I'm generating an app, I have to be certain the underlying AI isn't injecting malicious code or skimming my data, which means we run into the AI black box problem.
Exactly, the issue the architecture targets. When you query a centralized AI model today, you are operating entirely on blind trust.
Total blind trust.
You have zero verifiable proof regarding what training data it used, how it weighted its parameters, or what it's actually doing with your prompt behind closed doors.
Right.
Running the AI inference is a smart contract on the internet computer, provides absolute transparency. The execution is deterministic, meaning the output can be mathematically verified by network consensus.
But if we have thousands of users vibe coding custom applications, that requires a staggering amount of computational power. And that brings us right back to the tokenomics.
It all connects.
If the AI is burning through compute, and compute is fueled by the reverse gas model,
Then the AI build-out creates a massive deflationary feedback loop.
wow, okay.
Yeah, every time an AI model vibe codes an application, tests it, and deploys it, it consumes cycles. And because cycles are strictly generated by burning the ICP token, explosive growth in AI cloud usage directly reduces the overall circulating supply of the token.
Which makes this the perfect time to examine the economic engine. If this network is going to support thousands of AI-generated subnets and enterprise-grade Swiss infrastructure, it needs a really resilient governance model to manage node providers and upgrades.
Definitely.
The network is directed by the NNS, the network nervous system.
The NNS is the decentralized brain of the protocol. Participants lock or stake their ICP tokens into entities called neurons. By staking your capital and actively voting on network proposals, everything from minor protocol patches to authorizing new node hardware, you are compensated with voting rewards.
But the Mission 70 proposal from the Definity Foundation is aggressively tearing up the old rulebook.
Oh, they threw it out completely.
Previously, the system heavily favored extreme long-term lockups. To maximize your voting rewards, you had to commit to an 8-year dissolve delay. The absolute minimum lockup just to participate in governance was 6 months.
Which is a long time in crypto.
Exactly. But Mission 70 slashes those parameters across the board. They are compressing the maximum staking delay down to 2 years and dropping the minimum from 6 months to a mere 2 weeks.
It represents a fundamental philosophical pivot regarding network security and liquidity.
So put yourself in the shoes of an investor or a developer holding these tokens. You are suddenly faced with a massive mathematical dilemma. A 6-month minimum lockup alienated casual users. But if you drop the minimum to 2 weeks, you create a highly liquid, dynamic democracy.
Which sounds good, but
The glaring risk is a bank run. If the broader crypto market crashes and everyone can unlock their tokens in 14 days, what stops a mass exodus?
right, and the Definity engineers mitigate that risk through targeted mathematical incentives. They are overhauling the dissolve delay bonus curve. Under the legacy system, the curve was linear. Your rewards scaled evenly day by day. Mission 70 introduces a convex curve, specifically utilizing a quadratic function where n equals 2.
Okay, let's translate that quadratic math into real-world behavior for the listener.
Sure. A convex curve basically means the incentive structure is incredibly asymmetric. If you stake for the minimum 2 weeks, you receive voting rewards, but they are mathematically suppressed. They start exceptionally small.
Got it.
However, as your time commitment increases toward that 2-year maximum, the reward multiplier ramps up aggressively. Furthermore, they increase the maximum bonus multiplier from 2 to 3.
Okay, so a huge jump.
Exactly. So while you can unlock in 2 weeks, the system economically punishes you with massive opportunity cost compared to the user who commits for the full 2 years.
That leaves a very specific group of users in a strange position, though. The documentation affectionately refers to early adopters who locked up for the maximum time as the 8-year gang.
The year gang.
If the new maximum is 2 years, do those long-term believers just lose their historical advantage?
The proposal actually includes a legacy provision to honor that alignment. Neurons that historically maintained an 8-year lockup are granted a special protocol flag. Assuming they do not initiate the dissolve process, they receive a dedicated 10% reward boost hard-coded until the end of 2030.
That's a nice touch. So what does this all mean when it comes time to actually take profits? Because Mission 70 tackles one more highly technical economic lever maturity modulation.
Yeah, this is a big one.
When your neuron votes, it earns maturity. To actually use that value, you convert maturity into liquid ICP tokens. But the network dynamically alters how many tokens you receive based on the real-time market price.
The objective of maturity modulation is essentially behavioral engineering. The protocol needs to discourage users from minting new tokens and dumping them on the open market when the price of ICP is already crashing.
Right.
The previous iteration of this system was an algorithmic nightmare. It utilized a complex 30-day average, cross-referenced with weekly returns, smooth over a 4-week mean.
I'm lost already.
Exactly. It was incredibly opaque to the average participant.
If the user needs a degree in quantitative finance just to understand their staking rewards, you've failed at user experience.
Totally. The Mission 70 overhaul replaces that opacity with a highly intuitive, level-based modulation. The protocol simply measures the short-term 7-day moving average price against the long-term 365-day moving average.
The psychology of that is brilliant. It serves as a mathematical damper on human panic.
Right.
If the broader market is crashing out of fear, the 7-day average will violently drop below the 365-day trend line. If you try to mint your maturity during that panic, the modulation algorithm slaps you with a proportional penalty. You receive fewer tokens.
It forces you to wait.
But if the 7-day price is surging above the yearly average, you are granted a slight bonus for minting into a strong market. It replaces convoluted formulas with a single, clear economic signal that naturally secures the network's steady-state operation.
It's so much cleaner.
Let's pull all of these massive structural changes together. The internet computer ecosystem is systematically executing a paradigm shift. They are building the infrastructure to force the industry to view blockchain not merely as a decentralized bank, but as a full-stack decentralized server.
And the architecture we've unpacked today really validates that ambition.
We've examined how the reverse gas model completely strips away Web3 user friction. We've decoded how Chain Fusion's threshold cryptography allows canisters to autonomously interact with legacy blockchains.
Right.
We've debated how the Swiss subnets provide the legal grounding required for enterprise data residency. And we've seen how the 2026 narrative of verifiable on-chain AI vibe coding, fueled by the aggressive new tokenomics of Mission 70, is engineered to drive unparalleled network consumption.
Rebuilding the entire concept of cloud computing from the bare metal up, utilizing multi-party computation and liquid democratic governance, it's a monumental technological undertaking.
For you, whether you are prepping for a high-level tech strategy meeting, constantly monitoring Web3 market cycles, or simply insanely curious about the underlying mechanics of the internet, understanding this specific architecture is a shortcut to seeing the potential future of digital infrastructure.
And it forces us to confront some deeply uncomfortable questions about digital ownership.
It really does.
If natural language vibe coding on platforms like caffeine.ai eventually allows literally anyone to spin up secure, private, ad-free applications on a decentralized network, what is the ultimate fate of the centralized data monopolies we rely on today?
Will they even survive?
Right. Will the next decade of the internet continue to be controlled by a handful of tech giants renting us opaque server space? Or will it splinter into millions of personal AI-generated subnets that you autonomously control?
That is the billion-dollar question. Imagine an internet where the like button you click doesn't feed behavioral data into an algorithm owned by a faceless corporation, but instead interacts with a transparent network you actually co-own and verify. It's a radically different vision for the web. Until next time, keep diving deep.